Hello and welcome to Module 3. My name is Karthik Chandy. I am a technical trainer with AWS, covering the APAC region. In Module 3, we will focus on security and compliance. Security on AWS is broadly distributed into two layers. Amazon Web Services manages the security of the cloud. In other words, the security of resources, including compute, storage, and networks, are handled by AWS. Security of the global infrastructure, consisting of regions, availability zones, and edge locations, are also handled by AWS. Customers manage security in the cloud. This includes patching operating systems and applications, securing access through firewall ports, and encrypting data where needed. Let's look into some of the physical security aspects managed by AWS. All AWS data centers are managed by trained security staff. These data centers are located in nondescript locations, and all staff working in these data centers have to be authorized and go through multiple layers of security. In addition, all server access is controlled through bastion or jump servers. Firewall devices block unauthorized access, and systems continuously monitor the infrastructure. In addition to the physical security, AWS also complies by multiple certifications and attestations to ensure that data is securely stored and accessed. For example, the payment card industry, or PCI standard, is one of the compliance standards that all AWS data centers comply with. Similarly, there are other certifications and accreditations that are supported across different regions. Some of these certifications and accreditations are region-specific. For example, the multi-tier cloud security standard only applies to the Singapore region, and the Information Security Registered Assessors Program, or IRAP, applies to the Sydney region. All communication to AWS is securely handled over SSL or TLS. Security groups can be configured to restrict unauthorized access by permitting specific system access through well-defined ports. In this example, the web servers can be accessed over the internet, and the app servers can only be accessed by systems in the web tier. Similarly, systems in the database tier can only be accessed by the app tier. All SSH and RDP access has been restricted to the corporate network's IP addresses. Let's move on to the AWS Identity and Access Management section. In this section, we will cover four main aspects: users, groups, policies, and roles. AWS Identity and Access Management, or IAM, is mainly used for two reasons. They are authentication and authorization. Let's start with authentication. When a user tries to log in to the management console, they are required to enter a username and a password. If a user prefers to use the AWS CLI, SDK, or API, they are required to authenticate using an access key and a secret access key. Every IAM user can be securely identified using their credentials. As the number of users grow, it is recommended to create groups, as the groups help manage users more efficiently. Permissions for users and groups can be configured in AWS IAM using a policy. A policy is defined using a JSON document and can be applied to users, groups, or roles. We will cover IAM roles a little later in this module. An IAM policy consists of several elements. In this policy, you can see two statements defined as SID. We can interpret the first SID as anyone using this policy is allowed as defined under effect to describe start and stop as defined under action, any instance as defined under resources, provided they log in from a specific IP address as defined under condition. The second statement permits downloading objects as defined by S3 get object from a bucket called example_bucket. Let us refer to the JSON policy using the AWS IAM policy icon. The AWS IAM policy can now be assigned to an IAM user or an IAM group. All users and groups using this policy will now be limited to the permissions defined in the policy. A policy may also be assigned to an IAM role. IAM roles, however, do not support long-term credentials like an IAM user. Credentials for an IAM role are only valid for a short period and can be renewed by a service called the AWS Security Token Service. These temporary credentials can now be used by an IAM user or another AWS resource by assuming the IAM role. Let's look at an example. Imagine you are hosting a Python application inside an Amazon EC2 instance. How would you permit the Python application to interact with the Amazon S3 bucket? One way is to embed the IAM credentials into the Python code. However, is this the right approach? A better option would be to use an IAM role that can be assigned to the EC2 instance as an instance profile. Let's look at an example. In step 1, when creating an instance, choose an AWS IAM role. In step 2, after creating the instance, log into the instance and install the Python application along with the AWS SDK for Python. The AWS SDK for Python would enable interaction with AWS services such as Amazon S3. It is important to note that as we are using an IAM role, AWS credentials don't have to be included in the Python code. In step 3, when the Python application tries to interact with an AWS service, credentials will be needed. However, as credentials were not included in the Python code, the AWS SDK would communicate with the Amazon EC2 metadata service that is accessible using the 169.254.169.254 address. The Amazon EC2 metadata service communicates with the AWS Security Token Service to gain access to temporary credentials. Finally, in step 4, the Python application uses the temporary credentials provided by the IAM role to communicate with Amazon S3. Temporary credentials consist of an access key, a secret access key, a session token, and a time to live option, which can be defined by the administrator. Some of the common use cases for temporary credentials are single sign-on federation, mobile user access, and cross-account authentication. Please note, AWS IAM authentication does not apply to OS or application authentication. Some of the best practices for AWS IAM are similar to the ones we use at our workplace today. Never provide root access for daily administration. Always grant users with least privilege, or even better, delegate permissions using IAM roles. As the user base increases, consider using groups to manage multiple users. Use multi-factor authentication. Have a strong password policy, etc. Rotate credentials for programmatic access. Use conditions in policies to make them more stringent. Monitor user activity, and so on. Let us now look at an AWS IAM demo. On the AWS